everyone, welcome back to my channel Learn Math with Priya. In this video, we are going to discuss the important MCQ questions from the chapter polynomial. If one zero of a quadratic polynomial, the polynomial is given as p of x is equal to kx square plus 3x plus 2 and one zero is 2. Okay, then the value of k is whenever they say one zero of quadratic polynomial, it is nothing but the value of x. So I'm going to substitute x equal to 2 so that my polynomial will become 0. P of 2 will be 0. So what is P of 2? That is k times 2 square. So wherever there is x, I'm going to substitute 2 plus 3 times of 2 plus k is equal to 0. So when I substitute the value of x as 2, okay, I will get my polynomial to be 0. Then only it is called 0 of a polynomial. So 2 square is 4, 4k plus 6 plus k is equal to 0. So 4k plus k is 5k plus 6 equal to 0. Transpose. So you will get 5k is equal to minus 6, which implies k is equal to minus 6 by 5. So the option is D. Question number 2, the graph of polynomial is shown in the below figure, then the number of zeros is. So the given polynomial graph cut the x-axis at three distinct points, isn't it? Hence the number of zeros will be option A, 3. Question number 3, if one of the zeros of quadratic polynomial is 2, then the value of k is. Again, what is p of x? P of x is x square plus 3x plus k. Okay, and one of the zeros is 2. So when I substitute the value of 2 in x, I'm going to get that polynomial 0, right? So p of 2. First, I need to find p of 2. So substitute x as 2 here. So 2 square plus 3 times 2 plus k equal to 0. So 4 plus 6 plus k is equal to 0. So 10 plus k is equal to 0, which implies k is equal to minus 10. So which is option B. Question number 4. A quadratic polynomial having sum and product of its zeros as 5 and 0 respectively. So they have given alpha plus beta, that is sum of the zeros is 5 and the product of the 0 is 0. So when I frame the quadratic polynomial, the formula is x square minus sum of the roots, that is sum of the zeros times x plus product of the zeros, that is alpha beta, isn't it? So it can be k times as well, where k is some constant. Okay, so k can be 1 sometimes, or it can be all the terms will be multiplied by some constant k. Okay, so x square, I'm substituting alpha plus beta minus 5x plus alpha beta, which is 0, right? And it is k times. So I can see the first expression as x square plus 5x. So this cannot be that polynomial for the given sum and product of the zeros. Similarly, c cannot be the polynomial and d cannot be a polynomial. How about b? So if I take x commonly outside, I will get x minus 5, isn't it? So kx, so k takes the value 2. So definitely the polynomial is going to be b 2x times x minus 5 for the given sum and product of the zeros. Question number 5, zeros of quadratic polynomial x square minus 5x plus 6r. So I want to find the solution of this quadratic equation, so I can split the middle term, right? The constant will be written, that is positive 6 should be written on top, and the middle term is minus 5. So I have to choose a combination where the product has to give 6 and the addition or subtraction has to give minus 5, right? So 3 times 2 is positive 6, but 3 plus 2 is positive 5, but I am having negative 5. So it is minus 3 and minus 2. So the polynomial can be splitted as x square minus 3x minus 2x plus 6 equal to 0. Now take x commonly outside. So it is x minus 3, and here if you take minus 2 commonly outside, again it is x minus 3 equal to 0. Again there is a common term x minus 3, take it outside, so remaining will be x minus 2 equal to 0. If I equate the separate term, x minus 3 equal to 0, x equal to 3, x minus 2 equal to 0, x equal to 2. So the zeros of polynomials are 3 and 2. It's positive, right? So the option is C. Question number 6. The zeros of quadratic polynomial x square plus 99x plus 127 are. So I want to know whether the zeros are going to be positive or negative, or one positive and one negative, or reciprocal of each other. So the product of zeros and sum of zeros I need to find, right? What is sum of the zeros? Alpha plus beta is minus b by a. So here it is ax square plus bx plus c. So when I compare this, I know a is equal to 1, b is equal to coefficient of x, which is 99, and c is equal to 127, isn't it? So minus b by a will be minus 99, and product of the roots will be c by a, that is equal to 127 by 1, that is equal to 127. So you can see here, when I multiply the two zeros, I'm going to get it positive. So either the two zeros will be positive or the two zeros will be negative, right? So because minus into minus will be plus, so alpha plus beta is equal to negative 99. So when I add the two zeros, I'm getting minus 99, which implies that the zeros are negative, isn't it? So when I multiply the two zeros, I'm going to get positive. So it can be either two positives or two negative, and the sum of zeros clarify that it is negative. So both are negative, which is option A. Question number 7, a quadratic polynomial, the product and sum of whose zeros. Generally, they will say sum and product. So, usually, students will misconcept the first number as sum and the second number as product. So, read the question very carefully. First, they have given product, okay, and they said the word respectively, which means you have to take that in order. Okay, so product alpha beta is equal to the first number, which is 5, and the sum. So alpha plus beta is going to be the second number. So you have to take the number as per in order. Okay. So now how I will frame the quadratic polynomial? So if I want to frame the quadratic polynomial in terms of x, it is k times x square minus sum of the roots into x plus product of the roots, isn't it? So I'm going to substitute the values here. So x square minus alpha plus beta is 8 times x plus product of the root is 5. So the option is A. Question number 8. If x minus 1 is a factor of polynomial, p of x equal to x cube plus ax square plus 2b, and they have given a plus b is equal to 4, then I need to find the value of a and b separately. So if I say x minus 1 is a factor of polynomial, I have to equate that factor to 0 so that I will get the value of x. So x is 1, isn't it? So now you substitute in the polynomial p of x, that is x cube plus ax square plus 2b. So when they said it's a factor of polynomial, when I substitute the factor x equal to 1 here, I will get that polynomial as 0, isn't it? So substitute x as 1, so it is 1 cube plus a1 square plus 2b equal to 0. So what is 1 cube? That is 1. 1 square is 1 times a is a plus 2b equal to 0. But I cannot find the value of a and b if there are two unknowns, isn't it? But the given is a plus b is equal to 4. So I am splitting 2b as b plus b. That is possible, isn't it? Because b plus b is 2b. Now replace a plus b as 4. So 1 plus 4 plus b is equal to 0. So this is 5 plus b equal to 0. B is equal to minus 5, isn't it? So which is option B. So if I substitute b is equal to minus 5 here, I will get a as 9, right? Because if I transpose plus minus minus, a minus 5 is equal to 4. So a is equal to 4 plus 5, which is 9. So instead of finding a as 9, I can immediately select the option B, because none of the other option as b is equal to minus 5. So the option is B. Question number 9. If alpha, beta or the zeros of quadratic polynomial, the p of x is x square minus k plus 6 times x plus 2 times of 2k minus 1, then the value of k. So I need to find the value of k, okay? And they have given the relation alpha plus beta, that is sum of the zeros is off of product of the zeros. So first I need to find sum of the zeros using the polynomial equation. So it is minus b by a. So from this polynomial I can filter what is a. A is 1, b is minus of k plus 6 coefficient of x, and c is 2 times of 2k minus 1. So b is already negative, so negative into negative will be positive, so it is just k plus 6 by 1, which is k plus 6, isn't it? So what is alpha beta? Alpha beta is c by a, that is equal to 2 times of 2k minus 1 divided by 1. So just simply I can write 2 times of 2k minus 1. Now represent using the relation alpha plus beta, that is k plus 6 is equal to half of alpha beta. So half times alpha beta is 2 times of 2k minus 1. So I am just cancelling 2 and 2. So it will be k plus 6 is equal to 2k minus 1. Transpose. So you will get k is equal to, so 6 minus 1 transpose this side will become plus 1, so it is 7. So 2k minus k is k. So k is equal to 7, which is option B. 10th question is a repeated question. Okay, but now, so come to question number 10, the quadratic polynomial, the sum of two zeros. So sum means alpha plus beta is equal to minus 5 and the product. So alpha beta is equal to 6. So this is a repeated question and this can be asked in a basic paper as well. Okay, if you're lucky, yeah, you will get it in standard paper too. So the quadratic polynomial is going to be p of x is k times, right? And it can be 1 as well. So x square minus sum of the root into x, that is alpha plus beta times x plus alpha beta. So I'm substituting x square alpha plus beta is minus 5 plus alpha beta is 6. Okay, so it is x square minus into minus plus 5x. So this is what they are checking, whether you are able to no give the right sign here. So plus 5x plus 6. So which is option A. Hope you are able to do all the MCQ questions along with me from the polynomial, and these questions are taken from the previous year's sample paper. If you know how to do this, you can face the exam so confidently. Let's meet in my next video with another set of MCQ questions from the same chapter polynomial. Until then, it's Priya signing off. Keep practicing and all the best for your examination. Thank you.